Hello everyone. Welcome to the demo of our final year project titled Cognitive Brain Estimation using Deep Learning. Our team, Surya, Kavya Srivaipava and Ashika Dulin developed this system to address a critical issue in neuroscience, identifying cognitive decline early through medical imaging. In this video, we'll walk you through the core working of our model, from dataset and pre-processing to model design, training, and predictions, along with real-time results. Cognitive age doesn't always match someone's real age. Due to stress, lifestyle, or neurological diseases like Alzheimer's, a brain can age faster. Our aim was to develop a model that can estimate this brain age just by analyzing MRI scans. For this, we used the IXI dataset, which contains T1 weighted MRI scans of over 500 healthy individuals. These images were already skull stripped and normalized, which means the non-brain elements were moved and pixel values standardized. This ensures our model trains consistently. Although the IXI dataset is pre-processed, we still performed essential steps to prepare it for model training. We resized the images to a uniform shape, converted them to grayscale if needed, and arranged them into structured folders for training, validation, and testing. Each scan is labeled with the subject's actual age, which becomes the ground truth for training. We also ensured that the data distribution across age groups was balanced to avoid bias in model prediction. Our model is based on a convolutional neural network or CNN, which is well suited for image-based tasks. The CNN architecture includes multiple convolutional layers to extract features like edges, textures, and patterns from brain scans. These are followed by max pooling layers to reduce spatial dimensions and dropout layers to prevent overfitting. We used ReLU activation in intermediate layers and a single neuron with linear activation in the output layer to predict age as a continuous value. The model was compiled with mean absolute error as a loss function and the ADAM optimizer for training. We trained the model using Python, TensorFlow, and Keras, splitting the data into 70% training, 50% validation, and 50% testing. The model was trained over several epochs, during which we continuously monitored the training and validation loss. We trained hyperparameters like learning rate, batch size, and the number of layers to improve performance. Our goal was to minimize the mean absolute error, which tells us on average how far the predicted brain age is from the actual chronological age. Let's now look at the model in action. Here, a user uploads a T1 weighted brain MRI scan into our system. The backend loads the trained CNN model, processes the image, and predicts the estimated cognitive age. Within a few seconds, the system displays the result. This age is what the model has learned based on patterns across hundreds of other brain scans. This output gives us a non-invasive estimate of whether the brain is aging normally or unusually fast. Here is the predicted result shown on screen. We can compare this value to the person's actual age. For example, if someone is 50 years old but their brain appears to be 60, this could be a sign of early cognitive aging. Conversely, if their brain appears younger than their age, it might indicate strong brain health. We also plotted predicted versus actual age and observed a clear correlation, indicating the model has learned meaningful features. To conclude, our project demonstrates how deep learning can be effectively applied to medical diagnostics. Brain age estimation can help healthcare professionals detect early cognitive decline, plan interventions, and track brain health over time. In the future, we aim to expand this model using 3D CNNs for better spatial accuracy and integrate more diverse datasets for generalization. We are also exploring a lightweight version of this tool as a web or mobile application for real-time use in hospitals or clinics. Thank you for watching our demo. We hope this project inspired you and we are proud to share our work.